And we're back. I want to give you right now 5 things that you need to know about taking antiderivatives, which is the same as saying taking or evaluating indefinite integrals. And this is not one of the 5, but if A and B are just kind of general equations here without specifying what they are, if the indefinite integral of A dx is equal to B, let me put a big if out here, then the derivative of B dx is equal to A. So integration and differentiation undo each other. So, conceptually that's not hard, but in particular cases it may be very hard to find the indefinite integral or the antiderivative of some expression. So the 5 things you must know are little shortcuts and observations that will help us find antiderivatives. So let's start out just with the first. And you've seen this illustrated in the previous lesson. And if we've got the integral of x to the n dx, then that indefinite integral will be x to the n plus 1 over n plus 1 plus a constant. And this is going to be for n not equal to -1, because 1 upon n is related to the logarithm, as we'll see in just a second, so that's a bit different. All right, so it's easy to integrate power functions because all you have to do is manipulate the exponent. So like differentiating power functions was easy, so is integrating. 2, the integral of e to the x dx is equal to e to the x plus a constant. And remember, when we were studying derivatives, e to the x is a strange function because its derivative is itself, and so its integral is itself as well. And 3, the integral of 1 upon x dx is equal to the natural log of x plus a constant. So there are 3 forms and their antiderivatives. 4 and 5 build upon the first 3. So 4 is that if I have the integral of a constant times a function, then I can take that constant outside. The constant times the integral will be the same thing. And that's real handy, just to pull constants outside integration. It also lets us, if we need to put a constant inside. Because if I want a k factor inside this integral, I would just have to put a 1 over k outside and the k inside. That's just the same as multiplying the integral by 1, since a constant k times 1 over k would just be 1. Okay, and a 5th thing, and when combined with the 4 above, this is really quite powerful, and this is what we mean when we say that the integral is a linear operator. This is true for both addition and subtraction. If I have the integral of the sum or the difference of 2 functions, that's equal to the integral of the first plus or minus the integral of the second. So we remember this by saying the integral of the sum is the sum of the integrals, or the integral of the difference is the difference of the integrals. And I've got time. Let me scroll up just a bit and give you at least one example here of the kind of problems we'd be talking about. So let's say example. Let's look at the integral of 5x cubed plus 3e to the x dx. And maybe I'll bracket these guys. Well, the first thing I observe is that this is equal to the integral of 5 x cubed dx plus the integral of 3 e to the x dx. So now I've got not one big problem, but I've got two smaller problems, and both of these are going to be quite easy for us to accomplish. Using 4 from above, this is 5 times a function, so that's equal to 5 times the integral of x cubed dx. And this is 3, a constant, times e to the x, and so that's equal to 3 times the integral of e to the x dx. I can move constants through the integral sign. I can't do that with variables, but I can do that with constants. Alright, now we're almost done. So this constant is out here waiting for the result, and then I'll multiply the result by that constant. Okay, x cubed, that was, let's scroll up here, 1. We talked about how we would take the integral of a power function, x to the n, just manipulate the exponents. It's x to the n plus 1 and then divided by n plus 1, and of course plus a constant. So what do we have here? We've got x cubed, so that's going to be x to the 4th, and then I have to divide by 4. Now it's plus a constant, plus 3, working on the second integral. The integral of e to the x, again above we saw that's just going to be e to the x plus a constant. Now we usually don't write the constant at this point. We usually just wait. Why? Because this is a constant plus another constant, so if you add two constants you still just have a constant. So we would maybe finalize this by just rearranging things a little bit here and saying 5/4 x to the 4th plus 3 e to the x plus a constant. And this constant, although it looks just like this one, it's combining these two. Alright, so sum of a constant is just a constant. And so that's a result. The integral of 5x cubed plus 3e to the x dx is this expression right here. And to check it, you can differentiate this expression and you should get this expression here back. The derivative of this guy will be this guy right here. Okay, so that's it till next time.